Hello everyone, how are you doing? Hope you are having a good reInvent. Yeah, yesterday we launched IPAM, and I'm really excited to share more detail about IPAM, talk more about it. And I'm Shovan Das, I'm a product manager in EC2 VPC. With me, Tom is there, he's a solution architect. So talking about IP addresses, right? Has it ever happened to you that you took out your favorite navigation app and entered the address, and somehow you followed all the right directions, but somehow you ended up in the wrong location? That has happened to me. You know, the address was right, but the city was wrong. So it just autofilled, and I landed up in the wrong place. So as I was working on IPAM, so I was thinking, could the app given me an alarm that, hey, you are going to the wrong place, your friend doesn't live there? Or I could have helped the city planners not to put the same address in two nearby cities next to each other. I don't know much about city planners, but at least for network planning, this IPAM will help you to put the right address on your VPCs and your AWS resources. So jumping right in, what we are going to cover today is, we'll talk about why we need IPAM, then we'll look at the details of IPAM, then we'll walk through some of the use cases. If you have a greenfield deployment or if you have a brownfield deployment, how you can use IPAM. And then we'll go through some advanced use cases, how to detect overlap CIDRs, how to create overlapping networks. And then finally, we'll have a console walkthrough, sort of a demo for IPAM. Now, when you start on AWS, so your network is small, the only thing you need is to put the right IP address on your VPC, because that's what determines how you will reach that VPC and what are the security policies of that VPC. And you can start with a spreadsheet. Your developer asks you an IP address, you look at the spreadsheet, give them an IP address. But what happens when you grow? So you add few more VPCs, then you add few more regions, and now when your developer asks for an IP address, you are just taking longer time. So our customers told us that, hey, can we have IP address faster? Can we assign IP address faster? So faster, better, automation, always good, right? So we chatted with our customers, asked them, apart from faster, what else do you need? So they said that, hey, we need to manage our routing tables and firewall in a better way. Why? Because when you start, what happens is you can put a CIDR on your VPC, and then when you create the next VPC, you put another CIDR, but they are fragmented. So at some point in time, you'll have a big route table and firewall entries to manage. It becomes complicated. And this problem is especially more in IPv6, where you can quickly fragment the IPv6 space, and then you'll have thousands of entries to manage. So essentially, what our customers told us that they want to have a big block. They will configure that big block. So let's say that aligns with your dev VPC. So that CIDR you put on your route tables and firewalls, configure how to reach your dev VPCs. And then whenever you create VPCs, just find out a CIDR from that space. But now you are not fragmenting. You have a single entry on your route table and firewalls. So then we asked, what else do you need? So our customers said that they need to monitor VPCs across all the accounts, across all the regions. Why? Because overlaps can happen, and you won't detect the overlap. So you will detect the overlap after 6 months, or whenever you connect those VPCs. And at that time, it's really expensive to fix. You have to re-IP or move one VPC. So customers said that, hey, we need to understand right away that we created overlapping VPCs. Then what happens is customers also told that they need to monitor the utilization statistics of their IP addresses, because before the peak season, they want to know, do they need more IP addresses? And they can proactively add those IP addresses. So finally, what happened is we asked, okay, what else do you need? So they said that we need something which helps us to troubleshoot. Why? Because anytime you have a networking issue or connectivity issue, the first thing you want to know, am I using the IP address at the right place in the right way? After you do the sanity check, then you go and do other troubleshooting. Then the other thing our customer told us that, not only that, we do routine compliance checks, audit checks, whenever we receive a traffic, we want to know if the IP address belongs to us. So some kind of auditing capability. So they said that, hey, can I go back in time and look what happened to that IP address, how it came to my network, and does it still belong to my network? So they gave us that feedback. Then finally, does any of you use Bring Your Own IP? Yes. We released this feature 2 years back, so great feature. It allows you to bring your own IP addresses. If you have use cases where you have a hard affinity to your IP addresses, you want to retain your reputation, so you use Bring Your Own IP. But our customers told that we want to share it across accounts. We want to improve the utilization, right? Did you needed that one? Okay, so we got it here now. But we took all this feedback and essentially built IPAM. And essentially, what IPAM does is 3 things. First, it allows you to automate IP address assignments. So now your developers can go to IPAM and ask for IP address, and they will get it in seconds. So no longer cutting tickets or asking IP addresses through emails. Second thing IPAM does is that it helps you monitor. So it will monitor all your IP addresses across all your regions, across all your accounts. You can come to IPAM, figure out, is there any overlap? Am I using the IP in the right way to my intentions? And you can also detect the statistics for capacity planning. The third thing it does is that it helps you to do retrospective analysis. It stores IP address information, and then you can go back and look what happened to an IP address. Use it for audit or troubleshooting or compliance reviews. So now we'll start with greenfield deployment. And I know like most of you have VPC, so you're more interested in the brownfield deployment. But greenfield deployment will help us to understand the features and the basic building blocks of IPAM, and then we'll go into the brownfield deployment. So how to use IPAM is actually quite simple. You just have to do 3 things to use IPAM. The first thing is you create an IPAM. So you will just create one single IPAM in one single region, but it will help you to manage your IPs across all the regions. One big benefit of IPAM is that you can actually choose which region you want to host IPAM. So it's a global service, but you can decide where you want to host IPAM. And most of our customers said that they want to host IPAM in the region where they have the maximum workloads. But other regions are also covered. So just one single IPAM for all accounts and all regions. Then what you do is you arrange your IP addresses based on your routing and security needs. So essentially, you create the hierarchical structure. And then final thing is that you put your business rules, because you want allocations to happen based on your intentions. You want dev accounts to get dev siders, prod accounts to get prod siders, so you can set those rules here. You can decide which region gets what IP addresses, and we will get into that more in detail. But you set these 3 things, and then you are ready to go. What you can do IPAM is that you can assign siders. Your developers can go and get siders. Then you can monitor, go to the IPAM central dashboard, and in that central dashboard, you will have all your VPCs, all your EIPs, all your IP addresses, and you can use it to monitor, do usage statistics, do capacity planning there. And then finally, IPAM has IP address information for 3 years, so it is tracking every movement of your IPAM, how it went from one EC2 instance to another EC2 instance, and you can go there, ask IPAM, I want to know what happened with my IP address, and IPAM will tell you all the information. So use it whenever you do quarterly reviews or compliance audits. So now let's get into the detail, right? So the first thing is that how do you arrange your IP address into routing and security domains? And here, one important concept that you have to understand is pool. So pool is a collection of siders, one sider or multiple sider. But the benefit of pool is that when you're automating your assignments, so your scripts are pointing to the pool. And when the pool is empty, so you add more siders. So the pool ID is not changing, so that always remains same. Siders you can add more siders, but the pool will remain the same. So your scripts are not changing. How it helps you in arranging IPs based on your routing and security domain is that you can split the pools into 2 halves or multiple halves. So by splitting it, you will create the hierarchical structure, because you take a big sider, then you can, half of it you can allocate it for one region, half of it you can allocate for another region, right? So let's see, let's go through some examples how it happens. So this is first example, and you took a big aggregate, so that is your AWS white cider. Now you divided it based on regions, because now you can, one single cider represents your routing to that region. So TGW configuration or DX configuration is very simple. Then you divide it into dev and prod accounts in each region, and now you can set up firewall or security group rules for dev ciders and prod ciders. They can be different. Another example is that you can take the same cider, same AWS wide pool, then you can first divide it based on your security domains, dev and prod, and then divide it across regions. And the third one is, let's say you have a big organization and you have multiple business units, and you have a requirement that one business unit shouldn't talk to another business unit. So in that case, you divide first across business units, set up your routing and security policies such that one IP address from one business unit cannot talk to IP addresses from other business units. And then you either follow example 1 or 2, divide it across regions, and then divide it across dev and prods. And here I have shown 3 or 4 layers of hierarchy, but you can create as many layers of hierarchy as you want. So essentially the point is that IPAM is flexible, and based on your needs, you can decide the structure how you want. So here are some templates, some examples, but it's up to you. So once you do that, the next thing you will do is set business rules, because now your developers can come to IPAM and ask for IP addresses, but still you want some rules, which IP is going to which region, which cider is being used for dev, which cider is being used for prod, so you want those rules. So you can set those rules. Before giving IP addresses, IPAM will consult your rule. If all the rule matches, IPAM will give it. If it doesn't match, then IPAM will fail the call. So let's look at the rules, right? Now, for this launch, we came up with 4 rules, and based on your feedback, we'll add more rules. To begin with, these 4 rules are: first, region. So you can say that this cider is for this region, and only VPCs and resources in that region can use that cider. So keeps your route table simple. Then you can say that, hey, this cider is for these particular principals or accounts or organizational units, and then, so if you have a structure where you can say that dev accounts can only have dev pools, prod accounts can only have prod pools. So that way you know that your IPs are not being misused. The third thing is that you can have tag-based allocation policy, so only resources with certain tags can get IP addresses from a pool. That's because normally you will arrange your resources based on some tags. So this will ensure that your tags and allocation policies have one-to-one matching. And the final thing is size, because you want to standardize, hey, the smallest VPC should be this much, the largest VPC should be this much. It will take care of over-provisioning or under-provisioning. So you can set up a size-based rule that minimum size of VPC should be what, maximum size should be what, and what should be the default size. So that will help you to manage the size of your VPCs. And that's it. So those are the 4 rules. If all those 4 rules match, IPAM will give ciders. Now, one of the typical question here is that, hey, does IPAM works only for VPC? It's integrated with the VPC flow, so you can use create VPC API, and IPAM will directly give IP addresses to that create VPC API. But in case you want to build container overlay networks, or you want to get ciders for your VPNs, for any other use case apart from VPC, so what you can do is that you can call IPAM, and there is an allocate cider API. So you can say that allocate cider 24, so it will give you a /24 cider, and then you can take that /24 cider and use it wherever you want. For example, you can build a container overlay network, you can give it to your VPNs. Now we are coming to the other use case of IPAM. We talked about automating IP addresses, so we are now talking about how you can monitor your VPCs. So the moment you turn on IPAM, what happens is IPAM is actually monitoring and creating an inventory of all your VPCs, whether they were created by IPAM or whether they were created by you before. So both VPCs and EIPs, both public IPs, right? So it comes here, then that's the list of all the inventories. Then IPAM will say that, hey, there is some overlap. If you use IPAM to create VPCs, IPAM won't create overlapping VPCs, but in case you acquired a VPC from an M&A or you created a VPC outside of IPAM or you had a prior VPC, so IPAM will tell you that it is overlapping. And it will also say compliance. So what does compliance mean? We talked about the 4 rules. If those 4 rules match, so then we'll say that the VPC is compliant. If one of the rules is not matching, for example, the VPC is in the wrong region, so we'll say IPAM is out of compliance. Not IPAM, the VPC is out of compliance. And then you can go and check why it is out of compliance. This one will be handy when you go to brownfield deployments, when you have prior VPCs and then you want to know whether they're compliant or not based on your routing and security policies. And IPAM is integrated with CloudWatch, so all the pool statistics and information is going to CloudWatch, and you can create CloudWatch alarms. So you can set up a threshold that, hey, if my US East pool is at 80% threshold, for example, I want an alarm, and at that point you add more CIDRs to that US East pool. Then let's chat about historical audit. This was one of the features which was hard to build, because when you're tracking IP addresses, all your IP addresses, I assume you will have thousands of IP addresses. Some customers will have even more. So when you have those much IP addresses, tracking each and every movement, each and every assignment of that IP address at scale is a difficult task. So we solved it, and what happens here is that, let's take an example. If you have a public EIP, so you are reviewing your firewall policies, and you saw that, hey, this EIP is allow listed. So, and you want to see that whether it is valid or not. So you go to IPAM, and it says that, yeah, that IP was allocated to your account, but then it moved account boundaries, and at some point it got deallocated from your account. So it no longer belongs to you. It went back to Amazon pool. So that means your allow list firewall rule is stale. So you might want to clean up that. But you can use IPAM for these kind of scenarios. The other is that, let's say for private IP address, one of your developer complains that, hey, last night my database servers was down for 2 hours. It is up now, but what happened in those 2 hours? So you can go to IPAM, and IPAM will tell you that, yeah, in the last 2 hours, actually there was an overlap. There was another VPC got created, there was an overlap, but now that VPC got deleted, so now it's fine, but you know that, okay, what was the root cause, and then you can build some process to fix it. Now, yeah, this is interesting one. So I assume you already have tons of VPCs. So how you can use IPAM? Actually, the first thing is that IPAM monitors all your VPCs, right? So you create an IPAM. The moment you create an IPAM, it starts monitoring all your VPC without you doing any actions. It discovers all your VPCs and then creates the inventory view. Then what you do is that you create your pools and allocation policies. So the moment you create your pools and allocation policies, IPAM starts backfilling all the VPCs into those pools with the allocation policies. If IPAM doesn't find a pool, so then IPAM will say that it's an unmanaged VPC. I couldn't find an IP address. If it finds a pool, but if all the 4 rules doesn't match, so it will say that, yeah, I found it, but it is out of compliance. Looks like in the past you created a VPC in the wrong region, or wrong account is using the wrong CIDRs. So you can get those kind of insights. Now, the other question is that, okay, now I know I can use it for my brownfield deployment, but then how do I start? How do I migrate to IPAM? So first thing is that you don't have to change your workflow. So you create your VPCs as you are creating. Start using IPAM for monitoring. So IPAM is just monitoring. Then application or region by region, you move to IPAM-based assignment. So you automate those CIDR assignments for a particular application or for a particular region, and then migrate towards IPAM. Once you are complete, then actually IPAM has a SCP policy. You can log down. You can say that from now onwards, all my VPC in my AWS organization needs to be created using IPAM. So without IPAM, if I'm not using IPAM, then no VPC should be created in my organization. So you can create that rule as well. So you can go that far and enforce it. Now, so here is the summary of all the workflows possible, right? This is the first one. So in the first workflow, what happens is, this is what happens today. Most likely, your developer will ask you for an IP address. You will go into your homegrown tool or spreadsheet, look for an IP address, give back to the developer. Developer will then take it and use that string or CIDR in the Terraform script or in the CloudFormation script, and they will create the VPC. So the first step here is that you just insert IPAM. So you'll get the monitoring advantage of IPAM. IPAM will give you automated CIDRs, so less errors, all the benefits of IPAM. Then later on, you can take yourself out. Then the developers can directly use IPAM as a self-servicing tool. So you get more time and you can work on more strategic projects and work on other things. But once that is done, then you can have final integration. So we just released Terraform PR last night. So Terraform is integrated, CloudFormation is integrated. So you just use IPAM. Developer calls the script, and the Terraform calls IPAM, gets the CIDR, creates the VPC. So in this world, actually, developer doesn't even know what is IP address. And one of the common question here is that, okay, now that's good. I can take care of my existing VPCs, but how do I take care of what happens if I have a hybrid network? So here, what happens today is that you're on-prem, you might have an on-prem IPAM, so you are getting CIDRs from on-prem IPAM, and then essentially handing over that CIDR to your spreadsheet, and that's how you are managing in AWS or your homegrown tool for that matter. So in this case, do the same thing, but give it to AWS IPAM, and then AWS IPAM will automate across all your regions, VPCs, do the monitoring in AWS. You can even create a static pool for on-prem, so which represents what you are using in on-prem. IPAM won't use it to allocate VPCs out of it, but if a VPC was created and it is conflicting with this on-prem static pool, so then IPAM will give you an alert that, hey, I found a VPC which is not conflicting with any other VPC, but it is actually conflicting with one of your on-prem deployments. So it will help you to troubleshoot routing issues if you have. Then, yeah, I'll hand it over to Tom. He will cover some of the advanced topics.
Thanks, Shravan.
Thanks, Tom.
Awesome. So we still have a walkthrough for you guys at the very end that will cover every single feature that Shravan has mentioned. But before that, I want to talk a little bit about bring your own IP space, about high availability of IPAM, about overlapping address space, and a bit of pricing. So bring your own IP is a feature we launched in 2018. Actually, Shravan was part of the team that has launched it. And it allows you to bring your own IPv4 and IPv6 public space into AWS and assign it to resources you run in AWS, and then have AWS advertise those IP address blocks on your behalf. And this is very relevant, especially if you build up some reputation in your address space, or if you have some allow lists that you would have to update if you change your IP addressing. So it's a very handy feature. With the launch of IPAM, we've actually added a number of improvements to bring your IP space. From improving how you can bring the space into your environment, how you can segment it across different accounts and regions, as well as how you can bring in your existing IP space into AWS. So let's dive into each one. So prior to IPAM, when you were bringing IP space into AWS, you could bring a block into each respective AWS account. And the smallest block on the IPv4 side would be a /24, which is 256 IP addresses, 255, sorry. And then each account would get that /24, 255 addresses, even if you only needed to use 10 addresses per account. So there would be a lot of IP address space wasted if you went with that approach. With IPAM, you can bring that address space once into the IPAM account and then subdivide it across your additional accounts. So you can improve the efficiency of how you're using your address space. Now, if you already have bring your own address space on AWS, already deployed in your accounts, it's actually very easy to bring that addressing into IPAM. All you need to do is allow IPAM to discover those IP addresses, take management, and it can then be used to reallocate that address space in a more efficient way. And all that happens on the control plane side, so there's no impact to your data plane. So if you have resources already using that public address space, there's no change. They still continue working as they were, just the management has changed. The other improvement is the simplified onboarding. So when you bring an address space, you actually have to prove to us, to AWS, that you own it. So there's a whole process of what you need to do that, update ROAs, and we'll talk about it in a second. and create private and private keys. I have an example to show you how that looks like. But it was a cumbersome process that you'd have to go through each time you were bringing another address block. With IPAM, you do it once, bring it into centralized account, approve it, prove it that you own it once, and then you can start subdividing. Now, the final option is the ability for you to, in IPAM, define that you want to advertise a particular bring your own IPv6 space out to the internet, or decide that you only want to use it internally within your VPCs. So in this example, I'm showing you first a range that's publicly advertisable. So you define it in your configuration. So that /33 would be your top-level pool. You subdivide it into regions, and then subdivide it into environments. And with saying it's publicly advertisable, you're asking AWS to advertise that address space to the internet. If you set up the no publicly advertisable flag, you're effectively saying that I still want to use this globally routable address space, but I don't want AWS to advertise it for me. It would only be relevant to specific VPCs, and to be able to communicate with that environment, you would have to use things like AWS Direct Connect or AWS VPN. And you can have both ranges operating in parallel, and maybe use them for different environments. Another interesting feature for IPAM is how it deals with overlapping address space. When you design your networks, obviously you want to avoid overlapping address space. It's actually pretty complicated to fix. So if you can do it in advance, make sure you're not overlapping. But there's scenarios where you might have clashing address space, and IPAM can help you figure out what to do. One example where you might have overlapping address space is if you have VPCs that are not connected, you don't plan to connect them in the future. Maybe the sandbox environments, all of them have the same IP block. Or another example could be where you have VPCs with one address range that's non-overlapping and a much larger address space that is overlapping that might be used for other purposes. This is a common scenario with our container environments where customers want to give IP addresses that are non-routable to the containers, and then when those containers need to leave that environment, they would use the routable space. So in those scenarios, when IPAM discovers those VPCs, it will flag that they're actually overlapping. So you can tell IPAM, hey, I'm okay with this overlap. I'm aware that this is overlapping. This is on purpose. Another scenario that you might see overlap in is more related to acquisitions, or if you're running multiple independent networks that would run the same address space. To solve that, you can create separate scopes. So IPAM allows you to create these containers called scopes, and within each scope, IP addresses have to be unique and non-overlapping, but think about each scope as an independent environment that you manage separately so you can overlap address space in each additional scope. So what about high availability? So Shovan mentioned earlier that when you decide on the IPAM hosted region, that's where your control plane for your IPAM will live. So usually that would be the region and account where you have the most resources. And then if you start subdividing your top-level pool, each region would get an allocation of whatever pool you give to it. And then when VPCs are created, those VPCs pull IP addresses from the regional pool. So those VPCs, or creation of those VPCs, doesn't need to connect to the IPAM hosted region. So all the API calls happen within the same region. And that has some implications towards how a high availability works here. So in the unlikely scenario that the IPAM hosted region becomes unavailable, you no longer can add additional CIDR ranges to your top-level pool, but you can continue creating VPCs in all the other regions, as long as you still have available address space. So they're completely independent. Now, similar scenario, another region where you have your regional pool might have an issue. At that point, just that region is affected. You can continue adding additional CIDRs to the top-level pool, and you can continue assigning addresses to VPCs in all of the other regions. Okay. From a pricing point of view, we're keeping it very simple. So the pricing is based on what you use, not on your planning. So you can create ranges, you can subdivide them, you can even create VPCs using those ranges. We will only charge you when you start allocating IP addresses from the bottom range. So if there are ENIs inside your VPC, network interfaces actually using IP addresses from each pool. So example here, we have a /16 VPC. That's 65,000 IP addresses. Say that was assigned by IPAM. And if that VPC only has 2,000 network interfaces, maybe 2,000 EC2 instances, IPAM will charge only for those 2,000 instances. And for the specifics for the pricing, you can check out our public documentation. All right, let's get to the walkthrough. So first thing you need to do when you get into IPAM, and it's under the VPC section, is to just create IPAM. When you start, nothing's going to be there. So you create IPAM, and I'm showing you the console. But as Shovan mentioned, you can use Terraform, you can use CloudFormation, you can use APIs. It's up to you. The simplest for the demonstration is the console. So then the next thing you need to do is effectively allow IPAM to allocate addresses and communicate with other accounts in regions. So you have to enable those permissions. And then select which regions you want IPAM to be able to deploy addresses into. And when that's completed, you'll get two scopes. These are two default scopes, private and public, that get created as soon as you create your IPAM deployment. So once you have IPAM ready, you can start creating your pools. So let's start with creating a private pool. And we need to make sure that we are in the private scope because we will be creating a private pool. So make sure you select the right scope from the dropdown and then create a pool. Because this is our top-level pool, our first pool, we don't have any other pool to select from. We just specify what address space we're interested in. In this case, it's private, so it will be IPv4. We don't have a region that we're assigning it to. And then we decide on what address block we want to allocate to our top-level pool. And in the future, we can keep expanding those ranges. In the example, I'm just going to use a single /14. So we have that /14 popping up in our private scope. So next, we can continue creating our pool hierarchy. So we go in again, create a pool, and then now, because we have the top-level pool, we can select that as our source pool for creation. Then we select the region we want to deploy that new pool into. And then finally, we figure out what IP address block we want to allocate. And there's two options. You can manually specify, hey, I want this particular range, or you can just say, give me the next available /16, and IPAM will just give it to you. So in this case, that's what I did. I said, give me an additional CIDR based on a /16. It's going to go to US East 1, and I have the range available there. Because I will be using this pool for creating VPCs, I can configure some of the business requirements or allocation rule settings here. So I can say, I can tell IPAM what size of VPCs I want to allow. And the biggest is going to be a /21, the smallest is /25. And if I don't provide any input, my default VPC is going to be a /24, 255 or 56 IP addresses. And then if I also want, I can add tags as additional requirements, but I'm skipping that for the demo. And then I repeat that multiple times, so now I have a pool in each region. In a normal environment, you will continue the hierarchy further, right? So for the sake of an example, I'm stopping the hierarchy at the regional level, but you would continue subdividing it however you want, maybe based on environments or business units, whatever you want. So once we have those pools created, we can start creating VPCs from the relevant pools. So all we need is the ID of the pool we created in a particular region. And then we can use that in the VPC creation call. And I'm going to show you here the CLI. Again, you can do the same thing in the console. You can do the same thing through APIs, CloudFormation, Terraform. But in the CLI, if you're creating the VPC, I'm specifying I want a VPC in US East 1. And I just need to provide the ID of the IPv4 pool. I don't provide any other information. So at this point, the rules I created earlier will kick in, and I'll get a default size VPC of a /24 with the next available IPv4 block. Okay. So now, once I created a bunch of VPCs, I can start looking at, are they compliant? Is there any overlap? what is the utilization of each one of my VPCs that I've just created. And if I want to zoom in into the utilization section, I can look at resources. And here I'm showing you two different resources. The top one is a subnet. The bottom one is a VPC. And in the context of a VPC, that IP usage percentage is showing you how many subnets you have allocated. So if you created a VPC and then created subnets out of the whole VPC size, that would be at 100%. But in the case of the subnet, we're telling you how many actual IP addresses are utilized out of a particular subnet you created. So it's a slightly different metric, so just be aware. And then as Shovan mentioned, you can start monitoring your pool, see what the utilization is, and if you're running hot, maybe 60, 70, 80% utilization, you can set up a CloudWatch alarm, and then you go in and expand your pools, whether the top-level pool or regional pools. Now, Shovan also mentioned that you can set up security control policies across your whole organization and say nobody can create VPCs unless they come from IPAM. So that would prevent anybody from accidentally creating VPCs with overlap, but say you haven't configured that, you still have, you allow your users to create VPCs however they want. So there could be a scenario when someone creates a VPC and the IP address block they use will overlap with something you already use in IPAM. IPAM will detect that and will tell you, hey, you have two VPCs now, both have ranges with another VPC that someone created somewhere else. You can take action and remediate. Another very cool feature is the ability to track historical usage of your IPs. And the example I'm showing here is a private IP address, 10.0.0.12, from a private scope. And what we can see here is first it was assigned to a particular instance and a network interface. At some point, that instance disappeared, and the IP address was assigned to another instance and another network interface and continues to do so because there's no end time. Okay, let's talk about bringing your own address space. So say you have an IPv6 range that you want to bring into AWS and use it in IPAM. What would you need to do? So the first thing you need to do, and that is done outside of IPAM, you have to do it on your own infrastructure, create a public and private key pair, and then create a certificate. Then you go into your regional internet registrar. So for US, that would be ARIN. For Europe, it would be RIPE. It's basically a body that manages the public address space. And then if you want AWS to advertise that address space on your behalf, you have to update route origin authorization record. So you can see here, the range we want to bring in is a /48. And we're saying we're allowing AWS autonomous system numbers, the ones you see there, 16509 and 14618, to advertise that IP address block on your behalf. And the other thing you need to do is you upload the certificate you just created also to the registrar information. So if anybody does a whois on your records, they can see that certificate. That's exactly what we will do to validate that you own the range. And then finally, provision the range in IPAM. So let's see how that's done. So we're creating another pool. This time, we're creating a pool in the public scope. Bring your own IP address space is using globally routable ranges, so it will be in the public scope. It would be the same if you were bringing a public IPv4 range. We're configuring it here to say that the pool that we're bringing, we want AWS to publicly advertise. There is an option to not publicly advertise it and then keeping it completely private. And then we decide what is the prefix going to be that we are adding here. And we're selecting a /32. And straight away below, we will generate a message from the prefix you're trying to add. And it will include information like the prefix, your account, the date. And then what we require you to do is copy that message and sign it with the private key you generated earlier. So now we have a signed message with your private key that can be decrypted with the public key that's stored on your certificate in the RIR. So we have the connection between your account, your range, and the ownership. So after that, the range will be approved, and you can start subdividing it without any additional hurdles. So in this case, what we will do is we will create a regional pool from that original range. So you can see here the source pool is the address block that we allocated earlier. We're specifying that this will go into US East 1. And because in this example, my hierarchy only has 2 levels, I will be using that range to allocate it to VPCs. So I have to tick or select the option that this will be used by EC2 or VPC. Then again, I can either select the specific range I want, or I can say, give me the next available one, and configure some rules here as well. For IPv6, all of the VPCs really are /56, so the rules become very simple here. So that's the only size we support today. So when I'm creating a VPC that will have IPv6, you'll notice that I also need an IPv4 call. So each VPC today requires both IPv4 and IPv6. We have launched earlier, maybe this week or a couple of weeks ago, the ability for you to have IPv6 only subnets, but the whole VPC still needs v4 and v6 addressing as the main CIDRs. So that's why in this request, I need to do 2 calls. I'm asking for a v4 pool, address from a v4 pool, as well as an address from a v6 pool. And from that point onwards, I get my VPC created. It will have both IPv6 range as well as an IPv4 range. So we'll actually have presence in both scopes. I'm showing you just the public scope and the fact that the VPC of a size /56 was created. Okay. That's it for the walkthrough. If you're interested with kind of reviewing networking fundamentals, you want to learn more about VPC components and the basics, there was a Net201 session that already happened, but it's available on demand. If you want to go more into the advanced VPC design constructs and learn about kind of what launches happened in the last year and during reInvent, there's a session, Net206, that's still available tomorrow morning if you're still here. All right. So with that, I want to thank you very much for coming. Hopefully that was useful. Please provide us feedback. Shovan and I will actually read every single line of feedback, so we learn and we update our sessions. Cool, thank you.